Superposition theorem means that we can alternatively scale and to find the current. So this is the basic theorem. Is alternatively scale the source to find the current flow in branch. And algebraically at the current. So this is a way to use a superposition theorem. Superposition theorem means, and there are in the network there are more than one power source. So that way start the power source. Power source can be the voltage source or current source. So for the voltage source and current source, we need to scale the source. Scale the source means that we have to short circuit the voltage source. Scaling means that this is for the voltage source. This is the voltage source. So voltage source we can draw it like this. So this is for the R internet, and this is the voltage E. So this is the scale source. Scale means that we short circuit the voltage source. This is what voltage source we scale. And similarly, we also use a current source. Current source. So current source means that this is the current source here. Current source is supplying. So in this case, this is also the R internet. So we scale the source means this is that we remove the current source. We remove the current source and we solve the problem. So scaling means so the voltage source and current source are composed of that in any network. So that according to the superposition theorem, we need to alternatively scale the source. Scaling the source means that for the voltage source you need to make the short circuit. For the current source you need to make the open circuit. And then it's algebraically at the current. Like this way we can solve the problem. Okay, I give you one example. So this is we have to utilize the superposition theorem. Use the superposition theorem and then determine the current through the 4-ohm resistor. So there are two sources. E1 is a 54 volt, E2 is a 48 volt. So this is a 24 volt and 48 volt. So R1, R2, R3 are given 24 ohm, 12 ohm, and 4 ohm. So we have to find the current in the 4-ohm resistor. So in this case, we need to short circuit the source alternatively. We have to scale the source. So this is E1 and E2. You need to scale the source. So you scale the E1, and then you find the all current flow into the branch. And then also you scale the E2, find the current also flow into the branch. So by this way you can calculate. So the all currents you have to add the algebraic sum. So in this case, how to scale the source? Firstly, you need to scale the 48 volt source. So scale 48 volt. So 48 volt source is scale means that this is a short circuit the 48 volt. So only the E1 left. So this is E1 is a 54 volt here. And this one is a R1 is a 24 ohm. So R2 is a 12 ohm. So this short circuit is a E2. So short circuit E2, so this is R3 is a 4 ohm. Okay, short circuit is E2. So there's a current that we're flowing. So you see how the current is flowing. So this is the scale for the volt source. So we scale for the volt, and then you have to find the current. How's the current flowing? So this is for 24 volt current flowing here. Then will be flowing like this. The current will be flowing 24 volt here like this. So this is it. So firstly, we have to find resistance. So the resistance means 12 ohm and the 4 ohms are parallel and series with the 24 ohm. So we can calculate. So this is that you can find as R2 there. R2 there means R1 plus R2 R3 divided by R2 plus R3. Then you call it R total. So the R1 is a 24 plus R2 R3. So R2 is 12. R3 is a 4. Divided by R2 plus R3. So there will be 12 plus 4. So this is 24 plus 48 divided by 16. So you got a 27 ohm. The total resistance is a 27 ohm we got. Then you can also find a current total. I total. I total is a E1 divided by the RT. So the E1 is a 54 volt. Total resistance is 27. So you got that 2 ampere. Okay, this 2 ampere current flow here. 2 ampere current flow to the passing to R1 and they meet the R2 and R3. So we want to find the 4 ohm resistance. So this is IR3. This is a 4 ohm resistance. Current we can calculate. How to calculate the I total multiplied with R2 divided by R2 plus R3. So the I total is how you can calculate. I total is 2 here. R2 is 12. R2 plus 12 plus 4. So you get 2 multiplied 12 divided by 16. So then we got the current in the resistor. This current is 1.5 ampere. So you see the current direction. Current direction going to this direction. So this is the IR31, IR3 dash. So by saving the 48 or so, firstly we calculate the total resistance and then we calculate the current into the R3 by this way. So this is the first thing. And then you also need to get the E1. We will get the E1 and then we also find the current. So the second one is the K 54 volt. So the K 54 volt means the E1 is a short circuit. The short circuit means that this is the R1. R1 is a 24 ohm. And this is the R2. R2 is a 12 ohm. And this is resistor, this voltage source. The voltage will be 48 volt. And this resistor is a R3. So R3 is a 4 ohm. So current will flow like this. So current will flow this direction. They also flow here. So this is this current is a IR3. So firstly you need to calculate the overall resistance R total. R total means R1 and R2 are connected in parallel, and then the R3 is connected in series. So then we have to calculate about the total resistance RT. So RT is equal to R3 plus R1 R2 divided by R1 plus R2. So we calculate the R3 is a 4 plus R1 is a 24 multiplied R2 is a 12. So R1 also 24, R2 is 12. So this is a 4 plus 24 into 12 divided by 36. So this is a 4 plus 8. So you call it 12 ohm. So the resistance will be there 12 ohm. After that you can calculate for the IR3. The dash. So this is called as E divided by R total. So E is at 48 volt. Current is at 12, so this is at 4 ampere. 4 ampere means the current direction will be there, the Z direction, opposite one. Then after this direction, this two current you see that different direction. When you get the E2 so current will be going to left side. When you get the 54 volt, current will be like flowing to the right side. So two currents are opposite. Therefore, you have to separate the two currents. IR3 is equal to IR3 double dash minus IR3 dash. So the IR3 double dash is a 4 minus IR3 dash is a 1.5. So you got a 2.5 ampere. 2.5 ampere going this way. So this is ways that we can find the current. So we can alternatively get a source and then we can find a current in the particular branch. So this is a superposition theory. Problem. There are two sources supplying the load. So E is a 36 volt R1 is 12 ohm, R2 is 6 ohm. The current is 9 ampere. So this source is two sources are supplying the loads. So we need to find the current flow through that R2 6 ohm resistor. So in this case, we have to alternatively K the source. Firstly, we K the E for the E source and find the current passing through the R2, and then you also need to K the 9 ohm, 9 ampere current source, and then you also find the current passing through the R2. And then those currents are same direction you have to add, and the opposite direction you have to subtract. So this is the way we have to solve. So firstly, we have to K the source. So we have to K the voltage source. K 36 volt source. So by K the 36 volt source, we are short circuit. Short circuit the voltage source. So R1 is a 12 ohm. So this is R2 is a 6 ohm. And the current flow through here, this is 9 ampere. So we K the source. We K the source and then we see how the currents will be flowing. So the 9 ampere current flows, so this current will flow to this direction. This one will flow like this. So this one is the current flowing. So in this case, 12 ohm resistor current we need to calculate. So the 9 ampere flowing into R1 and R2. So we want to find the R2 current. Therefore, we can calculate IR2. So this is the I total multiply R1 divided by R1 plus R2. So the I total is a 9 ampere. Multiply R1. R1 is 12. Then R1 plus R2 is 12 plus 6. So 9 multiplied 12 divided by 18. You got a 6 ampere. The 6 ampere current flow downward. So this is the IR2 we got. And similarly, we also need to calculate the current. So we need to get the 9 ampere source. So that we get the 9 ampere source and find the current into the R2. The second condition. So this is the K 9 ampere source. Okay, if you get the 9 ampere source, this is we can calculate current like this. R1 is a 12 ohm. So R2 is a 6 ohm. This is 9 ampere source, so then we use the voltage is 36 volt. So eliminate. So in this case, we find the elimination area for me. This is the current flowing in this direction. So in this case, we can find the current. So we find the total resistance and the divided by voltage. You call the current I. IR2 you got. So this is IR2 you can calculate. So E divided by the R1 plus R2. So E is the 36 volt. R1 is 12 plus R2 is 6. So 36 divided by 18. So 2 ampere. IR2 is going down 2 ampere. So IR1, IR2. So this is IR2 dash. That way the IR2 double dash. So all currents are same direction, so you get S. So therefore that you can calculate IR2 is equal to IR2 dash plus IR2 double dash. So just you get a 6 plus 2. You got the 8 ampere power. So by this way, you can find the current. So in this case, this is for the voltage source and the current source are two sources. So you have to alternatively K the source. K the voltage source and find the current flow to the R2, and then K the current source, find the current flow to the R2. Then the two currents are same direction. You have to add. Otherwise, you have to subtract. So this is one where you get Thevenins theorem. So Thevenins theorem means we want to find the current in the particular branch. For example, this circuit here, you want to find the current in the 6 ohm, then we can utilize the Thevenins theorem. Thevenins theorem means that in the power circuit, there are many sources. Many sources are that they are supplying. In this case, we want to find the current flowing to the particular branch, then we can utilize the Thevenins theorem. So this is for the Thevenins theorem. We can draw it circuit here. This voltage is E, and this resistance is R1. And this one is R2, and this is the R3. We call like this. And this one, another resistor is a RL. So we want to find the current in RL. Okay, we want to find the current in RL. They are the different. Voltage E is supplying. So those are resistors are R1, R2, R3, and the RL. We want to find the current flowing into the RL. So according to Darwin's theorem, first step what you have to do is you have to remove the branch in which you want to find the current. So this is step one. Remove the branch. In which the current need to be determined. The current need to be calculated. The first step. First step is that we remove the branch in which the current needs to be calculated, so that we remove the branch. So RL current we want, current flow into the RL we want, so that we remove the RL. So by removing the RL, that's what we let is this is the E here. So this is the R1, and this is R2, and this is R3. So we take out the RL. We take out the RL. And then, second step, K the source. K the source. K the source means there are two kinds of source, voltage source and the current source. So to K the voltage source, you need to short circuit the voltage source. To K the current source, you need to remove the current source. So in this case, we got the voltage source E. So this voltage source is removed. So you got the R2, this is the R1. So this is R3. So by removing, so you can see what will happen. R1 is a bypass. Short circuit the bypass means the R1 will just appear. Only thing you can see is this is R2 and this is R3. They will be left. So this one. So this is step 2. And at the step 2, you also need to find the resistance across the terminal. So this is the step 3 you have to find. Calculate the resistance across the terminal. Determine the resistance across the terminal. So that you find the resistance across terminal means this is that we can calculate the RT. RT you can calculate. Then we the R2 plus the R3. So then we R2, R3 divided by R2 plus R3. So we find the RT. This is step 3. And step 4. So reconnect the source and find the voltage across the terminal. This is reconnect the source. And find the voltage across terminal. So this is the R2, this is the R3. So this is the voltage. This voltage is the VTH. So we can find the voltage. How to find the voltage? This voltage E is across the R1. E across the R1 means this voltage across the R1 also. This is the E. So that we can see the voltage E. Voltage E across the R2 and R3. So therefore you can use the position divider theorem. So that EDH you can calculate. EDH is equal to E multiplied R3 by R2 plus R3. So you call it EDH. So this is that we can calculate. And then final step is that you can find the current by substitution as a formula. So this is a step 5. So the current IRS is equal to EDH divided by RDH plus RS. So that in this case, you can calculate the substitute formula here. ED is E multiply R3 divided by R2 plus R3. And RDH we already calculate. RDH means R2 R3 divided by R2 plus R3 plus RS. And you call the current in the branch. So by this way we can solve the Thevenins theorem. This is the way to solve the Thevenins theorem. Okay, so we need to find a current through the 10 ohm resistor. So find a current through the 10 ohm resistor by using the Thevenins theorem. So we have to follow the steps. First step, you need to remove the branch in which the current to be calculated. So in this case, 10 ohm resistor, we want to find the current, so that we have to remove the 10 ohm resistor branch. So this is we remove the 10 ohm resistor. So this is for the 3 ohm R1 and the R2 6 ohm will be left. So we remove the 10 ohm resistor. Okay, so this is remove. This is for that we follow the step 1. And step 2, scale the source. Scale the source means that for this 9 volt is to be killed. So step 2, 9 volt is to be killed. So this is the scale the source. So R1 is a 3 ohm. So R2 is a 6 ohm. So scale the source. And 3. 3 means that we have to find the resistance. So the determine the resistance across the terminal. So this resistance across the terminal needs to be 5. So this is for the RDH. RDH you can calculate. So you can calculate RDH. This is a 3 ohm and 6 ohm parallel. 3 multiplied 6 divided by 3 plus 6. So this is 18 divided by 9. So you got a 2 ohm. RDH at 2 ohm. We calculate. And after that, reconnect the source and find the body across the terminal. So that we reconnect the source. Reconnect the source is a 9 volt body is you reconnect. So this is a 9 volt. So this will be R1 is 3 ohm. R2 is a 6 ohm. So this body will use EDH. So we find the EDH means that this is a 2 resistor, R1 and R2 are series to the 9 volt voltage. So that we can find the EDH. EDH we can calculate, the potential divided out we can utilize. So EDH is given 9 volt multiply R2 divided by R1 plus R2. So this is 9 multiply R2 is 6, R1 plus R2 is 3 plus 6. So 9 multiply 6 by 9, so you got a 6 volt. So voltage will is a 6 volt. So that will be the step 4. And final step 5 you can find the current. 10 ohm is the current. Find the formula. So that we can find the current. So R in 10 ohm. So this is the EDH divided by 10 ohm plus RDH. So EDH we can calculate is a 6 volt. 10 plus RDH we already calculate. This RDH is at 2. So this is a 6 divided by 12. So you got a 0.5 ampere. The current flow into the 10 ohm resistor is 0.5 ampere. So we got circuit. Thevenins equivalent circuit is this circuit. EDH and RDH are connected in series. So this is the Thevenins equivalent. Thevenins equivalent. This is the EDH and RDH are connected in series. And that will be the terminal will be the RS. So this is for the Thevenins equivalent circuit. So we can draw a Thevenins equivalent circuit. EDH and RDH are connected in series and RL will be connected like this. So because of this one in a digital circuit, we have to find the Thevenin equivalent voltage. Thevenin equivalent voltage means that you have to find the voltage across it. Firstly, you need to open the R3. So, to find the Thevenin equivalent, step one is you have to remove the R3. Remove the R3. Okay, so R3 is removed. So this is what Thevenin equivalent circuit across the R3. We have to find it across R3. So the program after Thevenin equivalent circuit across the R3. So this is the current source. Current source 12 ampere is supplying the resistor 4 ohm, 2 ohm, and R3 7 ohm. So R3 is the terminal. So we want to find the Thevenin equivalent circuit across the R3. So to determine the Thevenin equivalent circuit across the R3, firstly we have to determine the Thevenin equivalent circuit. Thevenin equivalent circuit EDA is the Thevenin voltage, R3 is the Thevenin resistance. So they are connected across the R, low resistance R. So this is the Thevenin equivalent. So we want to find the EDA, we need to find the RTH, so that will be able to determine the Thevenin equivalent. So to determine the Thevenin equivalent, the first step is that you need to remove the R3. So remove the R3 is going out, so only the 12 ohm will be left. So this for the voltage source is 12, current source is 12 ampere, and the resistor R1 is 4 ohm, and resistor R2 is 2 ohm. So R3 is removed. So this is for the remove the R3. And then step 2, you need to scale the source. So step 2 is scale the source. So we remove the R3, then step 2 is that you have to scale the source. Scale the source means that now the current source is here. For this source you need to make the short circuit. Current source you need to make the open circuit. So now we make the open circuit. 12 ampere current source is open circuit. So the R1, 4 ohm, and the R2, 2 ohm are left. So this is the terminal. This resistor will be the RTH. So then you can find the total resistance. So number 3, we find the total resistance RTH. RTH you can calculate. So 2 ohm and the 4 ohm will add together. The RTH is equal to R1 plus R2. So 2, R1 is a 4 plus R2 is 2. So you got a 6 ohm. 2 ohm and then 4 ohm you add together, that will be a 6 ohm. So this is the RTH. And then we also need to find the EDH. EDH means the current flow into the I2 and the I flow in, so that you can find the EDH. So how to find the EDH? EDH means that the current will flow in, so that the current will, when you make it open, the current will flow in like this. So this is for the current is a 12 ampere. The source, this is a 4 ohm, this is 2 ohm. So this across the voltage is the EDH. We how the current will be flowing. 12 ampere current cannot flow through the 2 ohm because of this one is open. This one open means that 12 ampere current can't flow through the 2 ohm, so they will all flow into the 4 ohm resistor. Because the open circuit, no current can flow. Current can only flow into the 4 ohm resistor. So the current flowing point is ever positive, flow out point is negative. So that this one top point with the positive, bottom with the negative. So the 12 ampere current flow to 4 ohm, then you can calculate the voltage. So this is the voltage across the 4 ohm. P4 ohm is equal to 12 multiplied 4. So you got the 48 volt. So P4 ohm is also equal to the EDH. They also the 48 volt. The EDH is the 48 volt we got. So then finally we can find a Thevenin equivalent circuit. Thevenin equivalent circuit is EDH and RDH are connected in series. So that Now you see EDA we got the 48 volt. So this 48 volt you see So this is EDA. And RDA. RDA is the resistor is a total gives a 6 ohm. So this one we call it out. So this is what the Thevenin equivalent circuit. This circuit is a Thevenin equivalent. So this is for Thevenin equivalent circuit. We can calculate like this. Equivalents are very similar. Thevenin equivalent circuit is a Thevenin equivalent voltage and resistance are connected in series. But northern equivalent is different. Northern equivalent current is IN and northern equivalent resistance are connected in parallel. So this is the RN. So this is for the northern equivalent circuit. Current voltage and resistance are series is a Thevenin equivalent circuit. And current and the resistance are parallel is a northern equivalent circuit. So for the Thevenin equivalent circuit, you will need to find the Thevenin voltage. For the northern, you need to find the northern current. For the Thevenin equivalent, you need to find the series resistance. For the northern, you need to find the parallel resistance. So this is then together to find. Okay, we solve the one problem. Okay, so northern equivalent circuit, you need to find the northern equivalent circuit external to 9 ohm resistor. So we have to find. So how to find? Firstly, we have to follow the similar step. Firstly, you have to remove the 9 ohm resistor. So this is for the step 1. The similar procedure we will utilize. Remove the 9 ohm resistor. Remove the 9 ohm resistor means only this resistor will let 4 ohm here. Then the 5 ohm, 10 ampere. So 9 ohm will be removed. Okay, so this is the first step. Remove the 9 ohm resistor. Second step, scale the source. Step 2, we scale the source. Scale the source means the voltage source has to be short circuit, current source has to be the open circuit. So now you see the current source is 10 ampere. So this is the scale the source means you scale the current. So this is the 4 ampere, 4 ohm here. This is the 5 ohm. So this is the so this is for the firstly remove. Second step connection K the source. And then third step. So find the equivalent resistance across the terminal. Find the equivalent resistance across the terminal. So find the equivalent resistance across the terminal. Find the equivalent resistance across terminal. So this is the final equivalent resistance across terminal means this is the northern equivalent resistance. So this terminal is the terminal here you remove. So we find the resistance across terminal. The 4 ohm and the 5 ohm. This resistance is Rn. So Rn you can calculate 4 plus 5. So this is a 9 ohm. So northern resistance is 9 ohm we got. And step 4. For the Thevenin theorem, you find the Thevenin voltage. Thevenin voltage across the terminal. And for the northern theorem, you have to find the northern current. So to find the Thevenin voltage, you leave with the open circuit. To find the northern current, you need to make a short circuit. So the reconnect the source and terminal are short. So then find the northern current. Find northern current. So how to find the northern current? Reconnect the source. And short circuit the terminal. So then reconnect the source means 10 ampere source we reconnect. So this is a 10 ampere source reconnect. So that's why it's parallel with the 5 ohm resistor. And similarly, 4 ohm resistor here. And this terminate short circuit. So this is Norton current we got. So the 10 ampere following, the 10 ampere will flow to the 2 branch. How the 10 ampere current is flowing? You can see that how 10 ampere current flowing. The current will flow into the you see the 2 directions. The current may flow into the 10 ampere, go to this way, or go to this way. The 2 parts. Part 1 is 10 ampere flowing, passing through the IN, passing through the 4 ohm. Part 2 is they flow to the 5 ohm. So this means that 10 ampere current is meet with the 2 resistor. 10 ampere current is meet with the 2 resistor. One is the 5 ohm, another is the 4 ohm. So IN. This IN is series with the 4 ohm resistor. So this means this IN is a 4 ohm resistor. So we go like this. This means the 10 ampere current flow, some current flow to the IN and 4 ohm, and another part of current flow to the 5 ohm. So that will be the part 1, and then one with the part 2. So the 10 ampere current is flowing, can meet with the 2 resistor in parallel. For IN is in series with the 4 ohm resistor. So in this case, we can find the IN. How do we use? We have to utilize the current divider theorem. Current divider theorem means IN you can calculate 10 ampere multiplied with opposite resistance is 5 ohm divided by 5 plus 4. So this becomes 50 divided by 9. So 50 divided by 9, you got the Norton current. So this Norton current will be the so 5.55 ampere. And then you can connect the circuit. So this is the Norton equivalent. This is the IN. IN is 5.55 ampere. And then this way is in parallel with the RN. So RN parallel is 9 ohm. So we can connect like this. So this is for the Norton equivalent. Norton equivalent. So this is how they find the Norton current. And finally, we can find the Norton equivalent. So this is step 5. Norton equivalent current. Norton equivalent circuit. I talk about the Thevenins superposition theorem, Thevenin and the Norton theorem. So those are the circuit theorems we widely use for the circuit solution. Superposition theorem means that we get alternate